Hello folks, today we are going to talk about calorimetry. So we're going to go through these problems. There are only 5 of them, but they're pretty long. So it takes a lot of work to do these. So bear with me. It's going to be a long podcast. Okay. When 12.3 grams of magnesium reacts with hydrochloric acid, it raises the temperature. What's the value of delta H? All right. Well, to be able to come up with delta H, let's start with just our thought process here. Our thought process is going to be the same for each one, but let me only go through that once. Your delta H is equal to kilojoules per mole of energy, typically, per mole of something in the equation, or per the reaction, actually. That's what we're trying to do, is kilojoules per the reaction, and so we have to figure it out per mole. All right. The problem is that we don't know those pieces of information. And so we have Q equals mc delta T as one of our equations that we use. And from Q, we can get kilojoules. Now remember that Q is in joules. So we have to go from joules to kilojoules. That's pretty easy. And we have mass here. We're given 12.3 grams of magnesium. So that gives us the ability to get to moles. Okay? So let's look at our equation. We have magnesium reacting with hydrochloric acid to give us magnesium chloride plus hydrogen gas. And it tells us that we're raising the temperature, so we know that our delta H is going to be negative. All right? Because we know we're getting the energy over here. All right? So we're getting some energy over here. So our delta H is going to be a negative number. We don't know what it's going to be, but we know it's going to be a negative number. Right? So we're putting in magnesium reacting with hydrochloric acid, and it's raising the temperature of the hydrochloric acid. So hydrochloric acid is essentially mainly water. So we're going to use the 4.18 as our C, and we have 1,000 grams of water, so we can use that. And our temperature change is these two numbers subtracted from each other, and that's 25.8. All right. So the first thing we do is we say that Q is equal to mc delta T. So that's equal to our mass, which is 1,000 grams of water, and our specific heat is 4.18 for water, and our temperature change is 25.8 degrees Celsius. All right. So that gives us a big number of 107,844 joules, which is 107.844 kilojoules. Now you'll notice I'm keeping way too many sig figs here when I do that. Again, I tend to do that when I do problems. I'll round at the end. Okay. All right. So what I also need to know here is it's talking about magnesium, and I have to convert from magnesium. I have to figure out moles of magnesium. So let's see, I have 12.3 grams of magnesium, and I have to convert from grams of magnesium to moles of magnesium. And for every mole of magnesium, 1 mole of magnesium weighs 24.30 grams. Right? So this gives me 0.5062 moles of magnesium. All right, so this tells me that let's just stop for a second, 0.562, try that again, 0.5 moles of magnesium will give us a lot of energy, and it raises this many joules of energy. So my delta H is going to be however many kilojoules of energy I raised. My delta H is going to be 107.844 kilojoules of energy, and I got that from 0.05, man, I'm having a hard time with that, 0.5062 moles of magnesium. So when I do that math, I end up getting 213 kilojoules of energy. So that's my delta H. And remember, it's negative. So my final answer for delta H is negative 213 kilojoules of energy. All right, it takes a lot of work, but that's what we're going to do for all of these. Right? We have 13.5 grams of ammonium nitrate. Ammonium nitrate, NH4NO3, and it dissolves in water, so it's dissolving into water, so it's dissolving into NH4 plus NO3 minus, and the water is cooling, so that's telling us that our delta H is going to be positive something. That means your energy is being added to the equation over here. We're adding energy over here. Right? So let's go ahead and go through this problem. We notice the temperature change of the water goes down, which is what we'd expect. So how much water do we have? We have 1,000 grams of water. So we're going to do the Q equals MC delta T thing. We're doing this for water. So we have 1,000 grams of water, and our C is 4.18 joules per gram degree Celsius, and our temperature is going down, and it's going down by 2.8 degrees. All right, and so that number is going to give me 11704 joules, which is 11.704 kilojoules. Right? Now remember, our delta H, when we figure it out, is going to be kilojoules per mole. And the mole we're talking about is ammonium nitrate. So the question is, how much is this in terms of moles? So we take 13.5 grams of ammonium nitrate, NH4NO3. We have to figure out how much NH4NO3 weighs. And again, I'm not going to waste your time doing that. I've done it for you. But nitrogen is 14, hydrogen's 1, the other nitrogen's 14, the oxygens are 16. Add them all up, and you get 80.0456 grams in 1 mole. And that's of ammonium nitrate. Am I done? No, oh yeah, well, for that part I am. Right? And that will give me 0.16865 moles of ammonium nitrate. Okay, well, that's okay. We're good with that. So now we can do delta H is equal to kilojoules per mole. And our kilojoules are equal to, let's see, kilojoules is 11.704 kilojoules. And our moles is 0.16865. Right, so when I do that math, I get 69.4. I have to get down to 3 sig figs now, kilojoules. All right, now remember, we said our delta H was positive, so our delta H is going to be positive 69.4 kilojoules. That's our final answer. All right, the combustion of 1.41 grams of propane. Okay, propane, let's do that up here. That's C. Propane is C3H8. And to combust it, I need oxygen. And I'm producing carbon dioxide. And I'm producing water. Let's see, this means I have to have 3 carbon dioxides. I have to have 4 waters. That means I've got 2 O2s. That's a 5 O2 that goes there. Okay, so that is my balanced chemical equation. What's the value of delta H? Well, combustion always generates energy, so your energy is over here. So your delta H is going to be a negative number. So let's go ahead and go through this problem. We have Q equals MC delta T, and that means we have 1,000 grams of water. We always do this for water, because for water we know the specific heat. And our change in temperature, oh, it just tells us it goes up by 16.8. How nice of them. We don't even have to do any math there to get that. Right? So that's going to be 70.224 joules, which is 70.224 kilojoules. All right, and I have to figure out how much. Let's see, I've got 1.41 grams of C3H8. So I have to figure out how much C3H8 weighs. Let's see, carbon weighs 12, and there are 3 of them. Hydrogen weighs 1, and there are 8 of them. So that's 44.096 grams per 1 mole of C3H8. Right, so that gives me, let's see, when I do that math out, I get 0.031967 moles of C3H8. Okay, so I have 1 mole of C3H8 giving me energy, so my delta H is going to be kilojoules. Let's see, how many kilojoules do I have? I have 70.224 kilojoules per mole, so that's 0.0319767. Gee, that's a small number. So when I do that division, I get a big number, which, let's see, a couple sig figs, 3 sig figs, so it's 2196 kilojoules, so that's going to round to 2200 kilojoules. This is negative, so my delta H is going to be a negative 2200 kilojoules for this reaction. Okay, 2 more problems. Once balanced, we have a single replacement reaction. Let's see, lithium, let's balance this. We have 2 lithiums over here. We've got 2 aluminums over here. We have 3 sulfates, we need 3. So that needs to be a 6 over here. 6 lithiums, we have 3 sulfates, 3 sulfates, we've got 2 aluminums. Okay, we are now balanced. All right. We have negative 2, so negative, our delta H is negative. What does that tell us? Well, that tells us the energy is going over here, 0.7 kilojoules, right, because it's exothermic. So we have 12.1 grams of lithium. How much will the temperature, okay, so here what we have to do is, if we're trying to figure out how much the temperature will go up, that's Q equals MC delta T. And we're talking about the water, how much will the water go up? We know the mass of the water, we know the specific heat of the water, we're trying to figure out the temperature of the water, which means we need to know the number of joules. Well, how do you figure out the number of joules? Well, we're given this equation up here, and we can figure out kilojoules. From that, we can get joules. So let's do that. We have 12.1 grams of lithium. Right? And we're going from grams of lithium to moles of lithium. And then from moles of lithium, we can go to kilojoules of energy. All right, well, we have to know how much lithium weighs. So we look lithium up on the periodic table, and it's 6.941 grams in 1 mole. And my kilojoules is 229.7, but this is the part we have to be very careful of, because we have 6 moles of lithium generating that much energy. So we have 6 moles of lithium generating that much energy. Okay, so that's going to give us 66.73798 kilojoules of energy, which is 66,737 or 738. Let's round, and that's joules of energy. Wow, that's a lot of energy. So we know now we have Q equals MC delta T. So we now have 66,738 joules. I'm doing Q equals MC delta T right now, equals M, which is, now we're talking about water, 1,000 grams of water at 4.18, and we're multiplying by the temperature change, and that's what we're trying to figure out. All right, so this much heat will raise 1,000 grams of water a certain temperature. Well, to solve for delta T, we have to move both of these things over there and divide by them. So we get 66,738, and we're dividing by 1,000, and we're dividing by 4.18. And when we do that math, we get a temperature differential of 14.6 degrees. Sorry, wrong one, my bad. 16 degrees Celsius. All right, so that's my temperature change. How much temperature that? So it's asking how much it will rise. That's your answer, 16 degrees. All right, for dissolving of sulfuric acid, H2SO4, when it is put in water, it dissolves into 2 H pluses and they're aqueous, plus 1 SO4, and that has a -2 charge, and that's aqueous. Right? And it gives us negative 236 kilojoules per mole. That means it's exothermic, so this thing is getting hot where I'm mixing this. 236 kilojoules, right, per mole of H2SO4, so that's good. So if 2.54 grams of sulfuric acid, what's final temperature? Okay, so we do exactly what we just did last time. We start with 2.54 grams of sulfuric acid. We have to convert that to moles of sulfuric acid. So we have to get rid of grams of H2SO4 and go to moles of H2SO4, because we have to figure out how much energy this is generating. And we figure out that sulfuric acid weighs 98.076 grams in 1 mole. But we're not done, because we want to know how much energy this gives us. So 1 mole of H2SO4, 1 mole of H2SO4 gives us 236 kilojoules of energy. So if I do this math, I get 6.11199 kilojoules of energy, which is the same as 6111.99 joules of energy. All right, I'm probably just going to go and round that as I go through that. Okay, so that's our joules of energy, and we know that Q equals mc delta T. So we now know our Q, so that is 6112 joules of energy is equal to the mass of the water, and we have 100 grams of water, and we have our specific heat, which is 4.18, and we want to figure out our delta T. So we divide 6.6112 by 100 by 4.18. All right, and that gives us, let's see, what did that give us? That gave us a temperature differential of 14.6 degrees. You say, cool, we're done. No, we're not. Read the question carefully. What is the final temperature of the water? Well, the temperature started at 20 degrees Celsius, and it went up by 14.6, so our total is going to be 34.6 degrees Celsius as our final temperature of our water. And that's it. All right, if you have questions, please see us in class. We'll be happy to help. Take care. Have a good one. Bye-bye.